C3f, energy. So we're going to look at two types of chemical reactions. One that is endothermic, which takes heat from the environment, so basically it feels like it cools down. And exothermic means that it gives out heat to the environment, so it feels like it gets hot, it heats things around it. In a chemical reaction, bonds are broken and made. The breaking of bonds is endothermic, you have to put energy in to break them. And making bonds is exothermic, so when a compound forms it gives out heat. You'll be asked how to measure energy changes. So here in this really dodgily, badly drawn diagram, I've got a glass jar with some fuel in it, a wick, and I've set fire to the end of it, so I've got a little candle burning there, and above it a beaker with some water in it and a thermometer. Now to measure the amount of energy that's given out, we use the equation. Energy given out is the mass of the water up here multiplied by the specific heat capacity of water, which is 4.2 joules per Kelvin per gram per Kelvin, and finally we'll multiply it by the change in temperature, the final temperature of the water minus the starting temperature of the water. If we put those numbers in, we'll give the energy that was given out by this fuel as it burned. Now we can use that to calculate the energy per gram. So the energy per gram is going to be this energy that we've calculated divided by the number of grams of fuel that was burned up during the time it was heating. So the starting mass of this whole beaker with the wick and the fuel in it minus the same equipment afterwards to figure out how much was burned. When you've done this calculation, you might be asked to figure out why the value that you get is different from one that other people might get, and you have to describe that energy is lost to the environment and suggest some improvements. So examples would be a lot of the heat generated here will escape to the air around it. Also, some of the heat is used to heat up this actual beaker. You're only using the specific heat capacity of the water, not the metal beaker or the glass thermometer. But ways to improve it would be to have it shielded and to have polystyrene, for example, surrounding this beaker, so all the heat, or as much as possible of the heat generated during burning, is transferred to the water.